Okay, so we're going to do the PowerPoint. This first one is just calculating molarity. And again, molarity is moles of solute over liters of solution. Okay, so in this problem, we're given 1.45 moles of KCl is dissolved, so that tells us it's our solute. We have 1.45 moles KCl, and we're given it's going to be a final volume of 875 liters or milliliters of solution. We need to remember our metric system. 1,000 milliliters is equal to 1 liter. Okay, so to get from milliliters to liters, we can divide by 1,000, or we can move the decimal place over by 3. So this would be 0.875 liters of solution. If we put that in our calculator, it's going to be 1.45 divided by 0.875, which will give us 1.66 molar, capital M for molar, which is also moles per liter. Okay, same unit. Capital M stands for moles per liter. In our second problem, we are going to be doing the same thing, but now we're starting with the mass of our solute. So we have grams. I went ahead and already got the molar mass of the solute, okay, because we're going to need that. And we're told the final volume of the solution is 2.15 liters. So our first step is to determine the moles of the solute. So we will take 57.2 grams, divide by the molar mass. So in 1 mole, 97.94 grams. Gives me 0.584 moles. The solute is our grams canceled out. Okay, so that's our moles, and then we want to find the concentration, so we're going to divide by the liters. So take that number, divide it by 2.15. And that gets us 0.272 molar. Okay, and our next types of problems, we're going to use molarity as a conversion factor. Okay, so like I mentioned before on the PowerPoint, what this molarity is telling us, we got a 0.4 molar solution. That's like saying there's 0.400 moles of the solute, which in this case is this compound, C6H8O7, citric acid, in 1 liter of solution. Okay, so that means we could write it as conversion factor 0.400 moles in 1 liter, or we can flip it, 1 liter, 0.400 moles. All right, so from that equality, we can write those 2 different conversion factors. In this one, we're asked how many grams of citric acid, C6H8O7, are present in 125 milliliters of 0.4 molar solution. Okay, so sometimes it can be kind of confusing where to start. So I'm going to actually write out a little roadmap here. Before we can get to grams, which is what we're trying to get to, that's what we're wanting to end with. Before we can get there, we have to figure out the moles first. And we can do that by using the volume of the solution and the molarity. So it's going to go from volume to, that's volume of solution, to moles of solute, to moles of solute, and then finally to grams of solute. And what are we going to use for each of these steps? For the first one, up in here, we'll use molarity as our conversion factor. And here we're going to use the normal molar mass. All right, so here's our roadmap and our steps. So, and I need to convert this volume to liters first, so I'll move the decimal place over 3 to 0.125 liters. And then I want to use one of these two conversion factors to convert from liters to moles. So that's going to be this first one that has liters on the bottom. 0.400 moles in 1 liter. So that my liters will cancel out and I'll be in moles. And then once I'm in moles, I'm just using molar mass to convert to grams. 192.12 grams in 1 mole. So my calculator, 0.125 times 0.4 times 192.12 gives me 9.61 grams of C6H8O7. Figure out what those units were. I want to check. Liters canceled out and moles canceled out, so I was indeed in grams, which is what the problem was asking for. Okay. Next one, we've got, we're actually given the grams of the compound, and we're asked how many milliliters, so we're going to go the other way here. We still have concentration that we're going to use it as a conversion factor. In this one, I'm trying to get to volume, and I'm starting with the mass. So I'm going to be, my roadmap looks a little different this time. Let's start with grams of solute, and I want to convert that to moles of solute, and then to my units are going to be milliliters. So actually I'm going to go, to get to milliliters, I have to start with liters of solution. Then I can convert to milliliters, which is simple to just move the decimal place over. We don't really have to put in a conversion factor for that step, but we will this time. Okay, and that's going to require molar mass off the jump. Molarity will be used as a conversion factor in our second step. So you'll see molarity is a conversion factor take us from moles of solute to liters of solution. That's what we used it for up here as well. Moles to liters there. Then this is just metric, simple metric conversion. All right, so 0.35 grams. Going to divide by the molar mass, and 1 mole, 151.91 grams. And then we're going to use molarity. Here's our molarity. Remember, that represents 0.1 moles per liter. Okay, and if we want to think about our units, so we've canceled out grams, we've got moles up here. We want to cancel out moles, and we want to get to liters, right? So let's write 0.1 on the bottom, 0.10 moles in 1 liter. If I solved here, that would give me liters of solution. The problem is asking for milliliters, so I want to go a step further and say there's 1,000 milliliters in 1 liter. So in my calculator, that's 0.35 divided by 151.91 divided by 0.1 times 1,000 gives me 23.0 milliliters. Or actually, got two sig figs, so 23 milliliters. All right, so that's all for unit or lecture 9 material. I'm going to stop here and we'll go to the lecture 10 PowerPoint.